So there's some numbers here about environmental benefits, some done recently that are provided on the Basin Authority website, and some done in the past. Just to emphasize, it's not my work just simply to say that there are numbers out there about environmental benefits. We need to go further than that because it's not just about those benefits for healthy vegetation, breeding events. It's relating those to environmental flows. And that's a difficult thing to do, hasn't been done. Trying to do it myself and starting to do that, we have a long way to go on that. I can also refer to some of my own work here. And this is about modeling dynamic trade-offs. This really sort of gets to the heart of the issue, which I don't have much time for. But basically, this is a stochastic dynamic programming model, which was calibrated to the Murray River. So there's various state variables, and what we're trying to do in this model is to say, hang on, how would we allocate the water compared to what actually happened from 2002 to 2009, vis-a-vis what we should have done if we were to maximize this social return function. That social return function takes into account on the left-hand side, on the side of the equal sign, the sorts of issues associated with irrigation, and then on the other side we've got these issues associated with the environment. So if you go through that, you take water away from irrigators in that first graph. Obviously that has a cost, you need to take that into account. But because we have water markets, the relative cost of that first bits of water you take away is actually quite minimal cost. The other side is just indicating that if you don't get those pulse flood events, you're going to get increasing costs over time, and that's exactly what happened in the Millennium Drought. So the bigger the break periods between a previous flood, the bigger the cost. So that's a convex function vis-a-vis the concave function associated with irrigated profits. You put the two things together, you have to make assumptions about parameters, and you can come up with some present value of costs of suboptimal environmental flow allocation of the Murray River, and it gets to be quite substantial over that period of time. Keeping in mind, of course, it was a drought period, so the costs will be substantially higher in the drought period than they would in a normal period. The model also generates when you would actually make the decision to generate those flows. Obviously, the more water you have, the bigger the pulse event, but it does generate pulse events, which is consistent. This comes from the model, but it's consistent with the sorts of things that people working in the environment have talked about. And then you can look at those numbers. Now, I wouldn't bet my house on those parameters, but there's ways we can talk about it. You can put a limit ceiling on the costs associated with the environment on a drought. And you can look at a variety of numbers. And you can actually, I think, not unreasonably get some very large numbers. I don't know what the number is, okay, the correct number, but I'm just saying that there's a range of numbers there. And at the upper end, you're talking about $3.5 billion extra if we had done a trade-off, a reallocation of water on the Murray-Darling Basin. And the A and the B is just simply the relating the environmental costs to the profits in agriculture. So it's 50% of those profits in 10 years, and B it's 50, and that's 100% after 15 years. So pick whatever you want, but there are indications of some very substantial gains. So I'm just on the last leg here in terms of sustainability planning and actions. Just some dot points. Richard mentioned it in his talk. I want to re-emphasize it. Okay? You've got to include communities and stakeholders in participatory planning processes. They have values, they have preferences. We need to know what they are. Does it mean that everybody's value and preferences gets taken care of? But we need to know what they are, and it needs to be recorded. That helps in looking at those trade-offs. Assets, there's some assets that communities really want to save that maybe not are listed in the key assets by the authority. We need to know that sort of thing. We need to evaluation, ground truth the sorts of numbers that we've got with the communities themselves. We need to promote incentives and processes that support resilience. I haven't addressed the issues of potential climate change. It doesn't matter whether there's climate change or not going to be climate change. We have climate variability within the basin, very substantial climate variability. So we obviously want to have processes that promote resilience. I would argue competitive water markets are one of those. And I would also argue we want to support robust government structures. So there's various ways to do that in terms of polycentric governance is the term that's used, but basically it's saying that there's different components to the government structures that allow us to operate if there's a breakdown of one part of the system. So the Commonwealth Environment Water Holder will hold a lot of water entitlements. So even if there are issues with the states, there'll still be water flows. If the states can get their act together and their water planning process is all better, this is sort of the allowing for robustness. And then the last slide is the statement of the obvious, but worth stating, given that it hasn't always happened. You've got to adopt risk-based decision frameworks. Not to do that in the planning processes is silly. I think we need to be careful about making irreversible actions. That's back to this pool of money, the $5.8 billion for subsidies. I think we need to promote cost-effective actions. So I would emphasise this, and I've been emphasising this for the last few years. Value for money for public expenditures. That seems to me a very important issue that we as economists can talk about, can state, and provide to the decision makers. And then finally, and not least, we do need to undertake data collection, experimentation, to be able to make sure that we can use, once we've got those developments, those planning decisions, that water is actually used effectively. It goes where it should go, and it's done in a way that generates good outcomes for ourselves. So thank you very much.